So good day everyone. This is Jay and I am with my partner O, and we're here today to explain one of the physics why. What's that sound all about? When a car approaches you with its horn sounding, the pitch seems to drop as the car passes. What is this phenomenon called? And why this happen? This phenomenon was first described in 1842 by the Austrian physicist Christian Doppler and is called the Doppler effect.
In 1845, Dutch chemist and meteorologist Buys Ballot tested the hypothesis using sound waves. He found that a sound's pitch was higher than the emitted frequency when the sound source approached an observer, and lower than the emitted frequency when the sound source moved farther away from the observer. This happened because the sound waves compress as they approach the observer. This increases the frequency of the wave and the pitch rises. As the waves recede, the observer will hear a lower pitch noise because the sound waves stretch out. This decreases the frequency of the wave and the pitch falls. Today, the Doppler effect even has application in robotics. It can also be used in some types of radar to measure the velocity of detected objects, and in echocardiograms to generate an assessment of the speed and the direction of the blood flow. It is also used in astronomy. The Doppler effect is used to calculate the speed at which planets, stars, and galaxies are approaching or receding from us. It even helps us to find and study new alien worlds.
When a source of sound and a listener are in motion relative to each other, the frequency of the sound heard by the listener is not the same as the source frequency. And to analyze the Doppler effect for sound, we'll work out on a relationship between the frequency shift and the velocities of source and listener relative to the medium through which the sound wave propagates.
If you find the siren too noisy and you keep your speakers away, what frequency you hear while moving away? And we will now tackle the Doppler effect for a moving listener and the stationary source with a sample problem. A police car's siren emits a sinusoidal wave with a frequency equal to 300 Hz. If the siren is at rest and the listener is moving away from it at 30 meters per second, what frequency does the listener hear? So we have to find first what is asked and what is given. And in this problem, we had given the frequency of the source or the Fs that is equal to 300 Hz. The velocity of the source, which is of course equal to 0 because the source is at rest. And the velocity of the listener, which is the VL, and it is equal to negative 30 meters per second. So why is it negative? So it is negative since the motion is in the direction from the source to the listener. And the speed of sound, or the letter V, is equals to 340 meters per second. So our target variable here is the frequency of the listener, which is equivalent to the FL. And we have here the equation for the frequency heard by the listener behind the source. We have here the FL, the V or the speed of sound, the VL, the velocity of the listener, the VS, the velocity of the source, and the Fs, the frequency emitted by the source. And for the solution, we have the equation FL is equals to V plus VL over V plus Vs times Fs. So, plug in for the values. FL is equals to 340 meters per second plus negative 30 meter per second over 340 meter per second plus 0 times 300 hertz. And we have FL is equals to 310 meter per second over 340 meter per second times 300 hertz. And then, cancel the meter per second. So, FL is equals to 310 divided by 340 is equals to 0.91 times 300 hertz. So, we have now the FL that is equals to 273 hertz. So, the frequency of the listener is equal to 273 hertz. And the source and the listener are moving apart. So, the frequency of the listener is less than the frequency of the source, which is equal to 300 hertz. Then we prove that if the listener is moving away from the source of the sound, the listener hears a sound of decreased frequency.
So now you learn that when a car approaches with its horn sounding, the pitch seems to drop when the car passes, and that is an example of the Doppler effect. So we will end this video by saying that keep moving, never give up. Who knows, you might be near to the source of your happiness. Just always remember that when the frequency is higher, the source is near. And that's all for today, and thank you for watching.